Yeah, this one is division, and yeah, that the second fraction here, the divisor, is already a fraction, so there's no need to apply cycle method on this one, okay? But I do need to apply it to the 4 1/2. Yep, that's true. So let's go ahead and do that, and well, let's go and write our, because we know we're going to get two new fractions out of this. Again, I'm not interested right now in changing the operation to multiplication, although you could with that keep change flip business. But I know that the 4 1/2 is negative, so I'm just going to apply that negative to my numerator right now so I don't forget it, okay? And then I'm looking at some cycle method here. So that'd be starting out with 4 times 2, which is 8, and then adding my numerator 1. 8 plus 1 is 9. So again, it's not just that it's 9, it's negative 9. And yeah, once again, I should have put my denominators in here just so I didn't forget those. But there they are. Okay, first mixed number had a denominator of 2. The second fraction has a denominator of 8. So there they are, written in. And yeah, the second fraction, by the way, is already 3/8. That's a proper fraction, so I just want to keep it proper, no problem. Okay, so a little bit less steps right here, but again, it's not that having the second number as a mixed number is more work. It's not that it's more hard, it's just that it's more work, that's all. All right, now that we've done that, what I'd like to do is take my division, because I don't want to divide, I would rather multiply with fractions. So there we go. As long as I do that, or if I do that, then I need to reciprocate that second fraction into 8/3. So I'm going to take my original fraction, negative 9/2, and now I'm going to multiply it by 8/3. This is the same problem. It's just shown a little differently. Yeah, we can't do that because we can change the operation because it's one of our math principles on this case. So it's not changing the actual values, it's only changing the way things look. And we can do that even with operations like that. So now that this is multiplication, let's go ahead and multiply these out. But before I do that, I know that there's one negative on this with the negative 9. So I know my answer will be a negative. Again, I'm going to apply it to the numerator, although you don't necessarily have to. But I do see some cross simplification in two cases right here. I see the 9 and 3. 9 and 3 are both divisible by 3, so that's what I'm going to do. I'm going to divide them by 3. 9 divided by 3 is 3 in the numerator. In the denominator, I got 3 divided by 3, which is 1. And then I got the 8 in purple and the 2 in black. Those are both divisible by 2, so let's go and divide those. Okay, so 8 divided by 2 is 4. And then in the denominator, 2 divided by 2 is 1. Okay, so what do I get out of this? In the numerator, I would have 3 times 4. It's already a negative, so I'm not worried about that. 3 times 4 is 12. In the denominator, I got 1 times 1, which is 1. Now, once again, do not write that into Canvas as negative 12 over 1, because it is technically not considered fully simplified. It's not simplified until you get rid of that divided by 1. It's still there. It's just we don't want to see it, which would then make it fully simplified. So I end up with negative 12 on this one. That would be my final answer. That's all I would have to type into the homework on the Canvas. And do keep in mind there's at least a few, I think, on Canvas that are just whole values like this. Otherwise, you'll see pretty much all the other answers are improper fractions. No